The next problem is a Carnot heat engine combined with a heat pump. So let's read the question. A Carnot heat engine. So what we do when we read this, we're just going to draw the blocks. Carnot engine. Carnot engine means reversible heat engine. And then you have your two blocks represent the thermal reservoir TH, TL. Heat engine is to extract heat from higher temperature reservoir and release the waste heat to lower temperature reservoir and produce work. So this is engine. So two reservoir at 800, and this is 800 Celsius and 20 Celsius. Half of the work it's used to power a Carnot heat pump. So we got to draw heat pump again, block diagrams. So heat pump, what does heat pump do? Heat pump is to extract heat from lower temperature and release, sorry, this is lower temperature. From lower temperature to higher temperature. This is your desired, and you have to have work input to make the pump work. So 1/2 of the work from the output from engine. So here the input is 1/2 of this W, because it says 1/2 the work produced from engine is used to power the heat pump. So they have a half of this W. Here's 1/2 of the W used to power the pump. From cold surrounding TL, it's 2 Celsius. Then to your room, it's 22 Celsius in the winter. You want to remain this temperature. So the house is losing heat. House is losing heat at 62 kilojoules per hour. So basically, this tells you QH has to equals 62,000 kilojoules per hour. Why? Because your house is losing heat at this speed. You want to remain the house at this temperature, so you have to supply whatever loss to the surrounding. So QH has to be equal to 62 kilojoules per hour. So if the house is determine the minimum rate of heat supply to the heat engine. So basically the heat supply to the heat engine, which is QH. So we are going to calculate for target is to calculate QH. So if we want to calculate QH, we need W. So we are going to find the work first. So for heat pump, we already know QH. We also know the temperature. So here, let's look at the COP. How do you calculate COP of heat pump? COP for heat pump, for all the heat engines, QH divided by the work in, right? It's divided by the work in. Here, the work in is 2/2 of the W. So this is the COP, coefficient of performance of the heat pump. Then this equation can be applied for any heat pump. So, but we have a Carnot heat pump. That means reversible heat pump. Reversible heat pump or heat engine, we can also use the temperature. So you have the equation of 1 minus, if you go to your slides, you will find this guy. So you have this equation too. So Here, do you know TL? Yes, we do. What's the TL? What's the TH? 22. So we can just do the calculation. So you have 1 over 1 minus 2 plus, again, convert it to Kelvin. So you have TH 22 plus 273. So if you do the calculation, this will give you about 14.76. So now your QH, do you know your QH? Of course you know your QH. So QH, you already know your QH, 62 kilojoules per hour. You can convert this to kilowatts because 1 hour equals 3600 seconds. So you can do the conversion. So then divide by 2/2 of the work. So here, so if you, this is 3600 here. So if you do the calculation, your work would be 2.34 kilowatts. So here, we just calculated work equals 2.34 kilowatts. So we want to calculate the QH. Again, for heat pump, your efficiency will have the desired heat engine, the desired the desired quantity, its work output divided by input QH. This is desired, and we already know the work. So because again it's Carnot heat engine, so you will have the equation. You can use the temperature to calculate the efficiency. So this equation, again, it's applied to all heat engine, reversible or irreversible. This one only for reversible, because Carnot is reversible, so we can use this one. But irreversible, you cannot use the temperature equation. So let's continue. So you will have 1 minus TL. TL, again, convert it to Kelvin. Then you have 800 at higher temperature plus 273. This will give you around 0.727 if my calculation is correct. So now your work divided by QH equals 0.727. We already know the work equals 2.34. So your QH will equals 2.34 divided by 0.727, give you 3.22 kilowatts. Yeah, that's this question.